Hello everyone, welcome to my channel. Today we will explore the differences between classical bit and quantum bit in a qubit. And by the end, you will understand what makes qubits so special and how to use Python and Qiskit to simulate a qubit. There are four learning objectives today. First, we will understand the differences between classical bit and quantum bit. Then we will learn the concept of superposition in qubit. We will use Python Qiskit to simulate a qubit, and we will observe and analyze measurement outcomes of a qubit in superposition. First, let's talk about quantum bit and classical bit. A classical bit is a unit in digital information, and it could be either 0 or 1. And for example, in this picture, you can see that we have a black and white image of letter C, and level 1 is for black color and level 0 is for white color. Different with classical bit, we have qubit, and the value of qubit could be not only in 0 or 1, it could be a superposition state. A superposition state could be visualized as a point in a Bloch sphere. And you can see that there are many points on a Bloch sphere. Therefore, it make quantum information is more powerful, can contain a lot of information compared with classical information. Mathematically, we can write quantum state as a linear combination of vector 0 and vector 1. So they are coefficient alpha and beta, which sum of square is equal to 1. Next, we will talk about quantum effect running quantum collapse. So when we have, for example, when we have a balance superposition, like the positive balance superposition here, when we look at it, or when we measure it, it could become either 0 or 1 with a probability of 50-50. With another quantum state, if it's closer to 0, then it will have higher chance to become 0. And on the other hand, if the quantum state is closer to 1, then when we observe that, then we have higher probability to achieve. Next, we will talk about quantum simulation. So in order to do quantum simulation, we can use Qiskit provided by IBM, and you can install Python first, then install Qiskit. So how to visualize bit 0 qubit quantum state 0. So here is the code visualize quantum state 0. Another code here is to visualize the qubit state 1. For any other quantum state, you can change your argument to achieve your preferred quantum state. Next, we will talk about how to simulate quantum superposition. Simulate quantum superposition. Special case superposition state. And to achieve a balanced superposition state, we will construct a quantum circuit and use Hadamard gate. So the Hadamard gate will rotate the quantum state 0 to the positive balance superposition state. And we will, when we want to observe or measure the value of a quantum state, it will be collapsed into either 0 or 1. And to do that, we will use quantum simulator QASM. We will measure them 1,000 times, and we will see that we approximately 50% to achieve 0. This is a quick journey about classical bit and quantum bit. you already understand the differences between classical bit and qubit. How the superposition work in the Bloch sphere and how to simulate that in Python and Qiskit. So install Python and Qiskit and try your work. Thanks for watching and see you in my next video.